we left off in 6.3 with one more example to go in your class. Now, can I do a quick recap? Parametric equations is what we're working on. If I do a quick recap, okay, parametric equations. When we talk about parametric equations, it's when we are going to be looking at two equations, right? An x equals and a y equals that are in terms of another parameter. So in most cases, in terms of t. One of the things I am going to show you today is how you can change your calculator mode, and you can graph this. Okay, but we went on the front page through ABC based on their different t values. We found x, y values, and we graphed it, right? We put them all together. We ended up with a full parabola. Full sideways parabola, that is. Now, when we got to this page, and I know, B's done in your notes, just not up here for right now. This was how do we take an x equals equation, y equals equation, and put them together to be 1. What was our process there? You had to pick one equation and solve for t. And then after we picked one equation and solved for t, we had to substitute it into the other. Now, one of the things you're going to be expected to do is not just solve it and, give an answer, because like we kind of had an answer right here as well, but be able to identify what is it. Okay, that's one of the things the directions and homework ask you to do. So in this case, we're able to identify it as a line. We could be able to give slope and intercept information. This one, we're able to identify it as a parabola opening to the right, I believe, because it was the one from the front page. Now, last one we have to do. Eliminate the parameter, identify the graph of the parametric curve. Basically, we're doing what we tried to do, what we did on the others. Eliminate the t. So, what's first step, generally speaking? Pick an equation and solve it for t.
Yeah.
Which one do we want to do there?
Neither.
What'd you say?
Neither.
Either or neither?
Neither.
Neither? Okay, I don't blame you. Neither is a good answer here. In all honesty, it doesn't matter because we're going to run into a snafu.
Yeah.
Okay, so, I'm going to go ahead and just pick the X one. Again, we're getting ready to run into a snafu. I'm telling you ahead of time, okay? And we're going to take a different route. But this is an option where you run into snafus. Okay, we're going to pick one of these and solve for t. Well, how do we solve for t here? Well, first of all, we need to get cosine t by itself. So we would divide by 2. So then I'm going to flip sides. Cosine t is equal to x over 2. How do we solve for t?
Inverse.
Technically, if we want to have it t equals, it is cosine inverse of x over 2. Nice, huh? Not really. Okay, and officially, what is our next step?
Plug it into y.
Plug it in to the other equation. So if it's y equals 2 times sine of what's t?
Cosine inverse x.
Got any information about what that is?
No.
Yeah, no, that's ugly. That's not something we work with, right? Now, I don't know. Trying to think if we could even figure it out. Might be able to graph it. I don't know. Don't do that right now, though. Okay, so we have a snafu. We have this problem of what is this mess? So we're going to take a plan B route here. Okay, and plan B, see that's plan A. When plan A fails, plan B, one of our options is to look at this on a parametric graph and see what the graph of these look like, and go from there. So this is where I said I was going to demonstrate on the calculator how to graph in parametric form. So grab your calculator. Let me switch my screen to my calculator. Now, check out mode. You have a mode button there in the, I guess, second row, yes? Check out mode. equations. If you go down to the row that says function, what's in the function row? Parametric. So let's arrow over to parametric and hit equals. And now, pull up your y equals screen. What do you notice on your y equals screen? Yeah. And for each set, there's x of t equals and y of t equals. So now you have a way that we can graph x equals 2 cosine t and y equals 2 sine t and figure out what this graph looks like. And then we can come up with an equation once we know a little bit more about this. So we're taking a different route, not your traditional. So x equals 2 cosine t. Notice when I hit my variable, where'd that t come from? I hit my normal variable button. Because we're in a different mode, it automatically populates a t. Okay? For y equals 2 sine variable. Now, what do you know about sine and cosine? They are what?
I want to say inverse, but my gosh, that's
No. They're trig functions. And what has to be true when we graph trig functions?
Make us look well. I know.
Oh, it works. Okay, maybe it doesn't matter. I was trying to lead you to saying that when you're doing something in a graph with trig functions, your mode needs to be in radians. However, I just looked at Katie's and hers is in degrees and she got,
Mine is in this.
what mode are you in?
Degree.
Okay. So why did Katie's work and yours didn't?
It's a degree.
So,
Oh, a little speck.
so mine I changed to radians. I didn't even look at it in degrees. I changed it to radians because I knew being in, with cosine and sine, what mode are we supposed to be in?
Great.
Radians. Now, it appears degree is not giving us the same answers. So safe thing to be would be in radians. So you changed to radians. Did it work now?
The radian made it worse. Why is it thick?
I have no idea.
Wait, I want to.
I put it in radian.
Too. She's a thick one. It just shrimples. No, I just have to go in.
I have no idea.
Maybe you're zoomed out.
How do you?
Oh, wait, that's.
Two.
No,
Alright.
she's. Okay, I just redid it. I don't know what you're on. I clicked Zoom 6. I listened to these girls talk. Well, I don't know. It graphed better the second time around for some reason.
I.
Okay.
Yeah, okay.
Now, wait. Why? You're in Zoom 6 also?
Well, no, mine did the same.
Oh, okay.
What do you click to get up?
Well, you did 6. Try it again. Because yours doesn't look the same as Katie's. Or mine.
Maybe you're in a different window.
Okay, what did you type in? You forgot your 2's. There we go. Okay. Okay. Your graph should look like mine, folks. I know, it's being a little crazy here, but your graph should look like mine. Can you get there eventually?
Yeah.
Minus all the tinkerings.
Right.
Now,
Yes.
what is this shape?
Oval.
Okay. What if I instead do, where is it? Number 5, z squared, which what z squared does is it squares up your x and y axis.
Circle.
And so now it's a circle. It is truly a circle, folks. Realize that z standard, it's a 10 by 10 screen, right? But is my calculator screen square?
No.
No. It's a rectangular screen that's showing a square format. So if I go back to Z standard, notice my horizontal tick marks are farther spaced apart than my vertical tick marks. When I go to Z square, now all my tick marks in every direction are equally spaced. So that just, normally Z standard works. Z squared gives us a better view of it, if that makes sense. Okay? Now, so we can agree that when we graph this, it looks like a circle, right? Okay. So with that in mind, and I'm going to write some tips on the other side here in a moment. What's the form of a circle equation? I don't know that we know this. I don't know if we've talked about it recently enough.
2 pi r.
That's circumference. I'm looking for formula, a circle formula. Or equation. I shouldn't
Pi
even say.
r squared.
Oh, so you're talking area. We got the circumference, we got the area. Like for instance, a parabola is y equals x squared, right?
Yes.
Or x equals y squared if we're going the other way.
Oh, I see.
Okay. An ellipse. Do you guys remember what ellipses were in terms of equations? Ellipses, they were ovals. A special case of an ellipse is a circle. And that's when it was x squared plus y squared terms. Okay? And that's where I need us to see that a graph of a circle is of the form. Actually, what I should get you to think is it's x squared plus y squared equals radius squared. That is a basic circle. Okay? That is a basic circle there, where it's x squared plus y squared equals r squared. Things change depending on the circle. So with that in mind, what we're going to do on this one, because we have proof that it is a circle, we're going to set up x squared plus y squared. Now, I'm not going to set up r squared because I don't know r. I need to find it. What can I fill in for x?
2 cosine.
So instead of saying x squared, I can say 2 cosine t quantity squared. Plus, what can I fill in for y squared? Or for y? 2 sine t quantity squared. Now, let's do some cleanup. What is 2 cosine when you square the quantity? Or when you square it? What does it become?
4
4,
cosine t squared.
or really what we should be saying is 4 cosine squared. Okay.
4 cosine squared t.
Uh-huh.
Okay. Does it really matter where the square is?
Depends if you're using parentheses or not. Here's what I'll say. I'm going to erase this. But this right here, two of those are the same. One of those is different.
All 3.
Two of them are the same.
The t's squared on the.
On this one does not work because this is saying 4 cosine of t squared. This is saying just a t is squared on this one. So we can't use that one. Now this one you could do because the squared is on the outside of the parentheses.
So is the t not squared?
The t is not squared. It's cosine that's squared. It's cosine t times cosine t. So it's the cosine, the function that's squared.
Okay.
Okay? Okay. Back to what we were in the middle of. Plus, what's 2 sine t when we square the quantity? 4 sine squared t. Okay. Notice anything?
Cosine squared plus sine squared.
What'd you say?
Cosine squared plus sine squared equals what?
Mm-hmm. And what do they have? What's in the way right now? A 4. But the 4 can act as a
8. What?
no.
No.
Just think GCF. Think GCF.
Factor it out. Yeah.
Yeah, factor it out. So if I factor this 4 out front, if we factor the 4 out front, then what's left? Cosine squared t plus sine squared t. And that's where Caitlin reminded us that that is 1 because it's one of our Pythagorean identities. Yes?
So it's just 4?
So it's equal to 4 times 1, which is indeed 4. Now, that's 4 that's on the right side. What was the left side of this originally?
R squared.
No.
R.
4 is our r
X
squared.
plus y squared. Is our r.
That's what we just found.
Oh, so it's 2.
No. 1 plus 2.
2 squared plus 2 squared. That would be.
How about just
Oh, wait.
the
no.
equation
Oh.
of our circle is x squared plus y squared equals 4.
Okay.
So now we're in that form of x squared plus y squared equals r squared. So this is a circle with a radius. What's my radius equal to here? 2, because r squared is 4, so then r is 2, with radius equals 2, and officially, because it's not like x plus or minus a number and y plus or minus a number, I'm going to say centered at the origin. In other words, it's not shifted anywhere. Okay, so one of our options is right here where this failed and we said, what the heck are we doing? My suggestion is going to be to check out the parametric graph to see what we might be looking for. Okay. Check out parametric graph to see what we might be looking for. Okay. That's my suggestion there. You saw one of the things I had to do is I had to try z squared to see what it really looked like. And this didn't affect this problem. But I'm wondering if it affects something in homework, because I said use larger interval if necessary. I have that in my notes, but I don't remember what that affects. So I'm just going to put it on here, make it a note, you know. I'm wondering if that has to do with a homework question that I don't remember off the top of my head. Okay. You have some homework time to get working on, yes? Okay. 7 through 24 on page 474. And I might show you one other quick thing on the calculator too.